We're ready to start assembling this thing so we can get it tacked and get it welded together. So I want to show you these shop blocks. So my friend Jason over at Fireball Tool, these are his what he calls shop blocks. Now this is a set that he gave me back when this is more what was a prototype, and these are now on the market, and you can pick these up from his website at Fireball Tools. And these are kind of like 1, 2, 3 blocks. Okay, you can use these in different stack ups in addition to 1, 2, 3 blocks. You see here's a 1, 2, 3 block. They have a magnet there on one side, and you can stick them to a 1, 2, 3 block or anything, you know, any kind of carbon steel. And they're not so magnetic that they're just going to attract a bunch of chips, but they work really well for getting different types of different stack up heights that you need. And he even said that he is working on a metric set for these blocks as well. But these come in various different, this is the imperial size right there, so these come in different sizes, 3/16, a quarter, you know, 3/8, half, 1 inch, things like that. Okay, so we're going to use this, we're going to use these blocks in our setup when we're pressing this together, and I'm going to show you how. So this ring right here, whenever I press this tube into this flange right there, I want a 1/2 inch gap at the bottom of that. Okay, so we're really only going into this about a 1/4 inch. So what I'm going to do, and this is going to be set up in, we're going to use our Dake arbor press for this. All right, so we'll set that down, and we're going to grab our 1/2 inch thick shop blocks right here, and we're going to set these down. We'll use all 4 of them here like this. And that's essentially just going to be a stop for our tube to press down against whenever we're doing our pressing. So we set our tube in there, and then do our pressing, and then that will evenly space a 1/2 inch from the face of the flange up to this tube right there, and then we can then get it tacked off. Okay, so that's going to work for this here. Now we're also going to use some of these shop blocks right here. So this spacing right there is 3 3/16. All right, 3 3/16 between the ring and this flange right there. So that's pretty simple with these shop blocks right here. You can use a 1, 2, 3 block. So these are just regular old 1, 2, 3 blocks, and I've got plenty of these, so we can put these on, just say all 4 of those ears right there. Then we'll take our shop blocks here, and these are the 3/16. And by the way, the production models of these now are improved, and he actually has the sizes laser etched on these blocks. So that's one of the new improvements to these production models of the blocks here. All right, so we'll be able to do our stack up. And this is exactly one of the reasons why Jason invented these, was just for little things like this. There's a million ways you can use these blocks, and this is just one way that I'm going to use it today. So I'm making a spacer using a 3 inch block and a 3/16 block right there, and then we're going to take our ring, and I'm going to put it on there, and then we are going to press this down. Okay, lightly press it down until we touch our blocks right there, and then I should be able to just tap those out of there. All right, and then I've got this bearing race right here that we can use. We can set that on there, and then we'll put a plate there and use that to press this down there together. All right. I'm going to use this fixture plate that I machined. That'll hold it nice and square where we want it. All right, here we go. Okay, it should be in there. I'm looking down inside, and I can see that the tube is touching the blocks down inside there. All right, we should be ready to go. All right, now we're going to go ahead. I'm going to get the welding area set up, the machine set up, and we're going to go ahead and tack this off really well, and then we'll press our other flange on there, our other ring, and then get it tacked on there as well. All right, I'm ready to start tacking this thing off. So we're going to be using the Everlast. This is the Power TIG 200 DV, and I just got it set at 110. I'm going to be using the finger control to blast our tacks on there, and I've got some 308 TIG filler rods right here. I've also got my little Starrett machinist square right here, and I've been using that to make sure that we are pressed in there nice and square, comparing the machine face of the flange up to the tube, and it looks right on. So I'll start off by putting several little tacks 180 out to make sure that we maintain our squareness. Still good after that. We should be, because it's pressed in there. It's an interference press, so it should be holding it nice and true. I decided, instead of pressing the ring on and getting it tacked on, I'm going to go ahead and weld this flange on and chuck this up and go ahead and machine that other side. It's going to be a little easier to machine that versus chucking that ring and getting that trued up. So that's the direction I'm going to go. Get it welded, get it machined, then we'll press the ring on, get that one welded on, and then we'll chuck this flange up and just machine this this ring, and then it should be done as far as the lathe work. There's our finished weld. Then let it cool down. I'm going to go ahead and wire brush it and repolish all this right here, get the discoloration off of it. I had one goof up right here where I slipped, and you can see it right there. I had to regrind my tungsten, but that's okay. It happens sometimes. Not too bad for a machinist. So we'll get this cleaned up, and then we'll go to the lathe and then we're going to do our counter bore here and get our face cleaned up. You can definitely see we've got a little bit more to take off there. That was 20 thousandths. Just keep going until this is cleaned up. This isn't real critical on this thickness right there, but we're gonna be really close to what we were on our original part. Got our face nice and clean, and so now we're going to finish cleaning up that counter bore there, and we're going to have to touch this tube a little bit and take a little bit out of that. I've got a depth set over here of a 1/2 inch. Set my cross dial here to 0 and just kind of go ahead and face out that inside a little bit so that we have our depth. This is going to be a finished counter bore diameter of 5.125. Using my 5 to 6 Mitutoyo here and my telescope gauge, and we'll get it right where it needs to be. All right, we're going to use a little cutting oil there to try to get our. We've got 2 little finish cuts to make. I want to see how that cutting oil does, if it'll improve the finish, and try to keep the chips from trying to gall by the insert there. Yeah, it looks good. It actually does a better job there. I didn't want to use much on this job. I'm just trying to keep it off the workpiece, but I'll wash it off with my solvent degreaser before I go to do any welding on it again. So this will be our final cut. Should be about 10 thousandths to bring it down there to size. Just using this brush and just putting a little bit on there. Keep my pliers handy in case the chips try to pack in right there and mess up the finish. Sometimes you just can't help it, and it does it. Especially when you get to the end of the cut, you gotta get ready to stop the machine. All right, I'm shooting for 5.126. That gives it about 1/1000th. I'm sure that there's some kind of piece that fits in that. It's like a register fits, and that's exactly what I hit on, was 126. All right, so we are there. We got to come in here. We'll deburr these sharp corners right there, and this side will be finished. Just another bar with a chamfering tool bit in there. Always keep this one set up and really just use it for this right here. Breaking those edges. All right, we're going to go ahead and start our little block stack up here for our ring now. And I wanted to mention this. I forgot to mention this earlier. You know, we're talking about our new shop blocks for my Fireball tool. So, you know, Jason, I'm fortunate that I consider Jason a good friend. You know, he and I, we keep in touch, and we communicate. not just about tools, not about his tools. We talk about work, projects, you know, what's going on in each other's lives and things like that. But he's just a good friend, and I've loved his tools ever since the first time that he sent me one of his squares. But he wants to offer all you guys a 5% discount for you know, anybody that wants to go to Fireball Tool to make a purchase for any of the tools there, no matter if it's the shop blocks or the mega squares, monster squares, anything that he's got over there. You can use the promo code ABOMB79 and you'll get 5% off, and that's just a standing promo code for all of the ABOMB79 viewers. Okay, so that was just totally Jason's idea, so got to thank him for that. So keep that in mind. All right, so we're gonna go ahead and do our stack up. As I said, we wanted 3 3/16, so I'm gonna put these 1, 2, 3 blocks. I've already measured these, by the way. These are just shop grade 1, 2, 3 blocks, and they're right on 3" using calipers. And then we're gonna use our 3/16 blocks here. Put those on top of our 1, 2, 3 blocks, and you can see he's actually got them sized for 1, 2, 3 blocks. Now that magnet's actually trying to pull it over just a little bit because of those holes in there, but that's okay. And we're going to put our ring on there. So we'll have to go to the press to start this because our tube is egg-shaped. And we will press that down until it touches squarely on all those spacers right there. All right, let's see if that'll do it right there. There we go. Okay, that looks like it. Looks like it's touching all of them. Should be good to go there. I've been able to pull these out by hand. I was just showing the last one right here. There goes one of the blocks right there. They were all snug in there, so we had a good fit. I'm using my 10" low profile chuck here to kind of add some mass and weight to hold the workpiece here and keep it from moving around. It's working out really good. It's gonna work out really good. I'm gonna go ahead and start welding in this bottom side right there. So on the top side there, where you know, the opposite side where I just welded, they've got it's a very small, just a fusion weld down in that fillet. So that's what I'm doing on this one. I'm not exactly sure why that was done that way, but that's how this one was made. So that's what I'm doing. I'm not adding any filler, I'm just doing a fusion weld. I've been trying to get the machine set right. I started off a little bit hot and I moved it down just a little ways. It says 107, but I still don't have the pedal all the way down. But I've got it just about to where it's at a comfortable position. Alright guys, this is the next day. I've got this piece cooled down. We got our welding done on our ring. Got to do a little bit of cleaning up on it and get rid of the discoloration. Really all we got left to do is we'll chuck it back up on this flange side here, and we've got to turn this diameter down to this diameter here. I left it a little bit oversized just so I can make it true with everything. And then we've got a little bit, it's hard to see probably on video, there's a little bit of a taper right there. I believe there's a piece that is just kind of pushed in here that's being clamped to it. So I'm gonna machine this taper right there. I use my angle protractor, and I'm getting about 6 to 7 degrees on that right there. So we'll just use the compound and just cut this little bit of a bevel right in there on this end right there, and just touch the face. Really doesn't need very much coming off that right there. And then after that, the lathe work will be done, and then we'll go to the mill, drill and tap our 4 holes. All right, we've got her chucked back up. I have not indicated it yet. You can see we've got some run out right there, but I did pretty good on getting it nice and square. So since we're not wobbly too much, we're going to go ahead and just true up the OD of this ring right here to get it close, and then I'll go to the face. Since this face right here was machined square to the other side, we'll use this to kind of square it up. But see, I need to get it close, because if we try to indicate this now, our needle will probably be jumping off there. And by the way, we do have our copper soft jaws in there so that the jaws are not digging into the flange. Copper gives you good holding power, but still allows the piece to slide and move across as it needs to. And it doesn't mar it up. And just using standard indicating practices right here. Loosen your low spots, tighten your high spots. And then usually you got to switch to the other 2 jaws. So there's our low, and that's our high. Now we're getting pretty good right there. So I want to go ahead and switch around here to the face and make sure that we're running nice and square to the axis, the axis of the spindle here. And you can see we're out just a little bit. That wasn't bad for just sticking it in there by hand and just, eyeballing it. So this is our low, so I'm going to bump it that way just a little bit. Or you can do this and kind of bump away from the indicator. You can come to this side. Whenever you see me holding something when I'm indicating it, it kind of serves 2 purposes. It sort of dampens the vibrations in the ring whenever you hit it, and also it kind of helps you feel. I know it's not very much movement, but you can just kind of, you get a better feel of it when you're holding on to it. I did the wrong one there. So there's our high. We're pretty close. All right, see, there's a low, there's a high. Just trying to split the difference. All I'm doing is I'm staring where that needle is running back and forth, and I want to make sure that we get both jaws within 1 to 2 thousandths of the same location every time I stop there. So that's 28, that's 29, 28, I'm sorry, 28, 27. So we're close. I'd call that squared up. And now I'm going to go ahead and run it back to the OD here, and we will go ahead and finish truing it up this way. I've got a lot of people that still enjoy seeing this stuff. I know I've showed it a lot on a lot of different videos, but to some people, they enjoy seeing it. They're still trying to learn. There's new people to the channel that haven't seen this stuff, and they're trying to learn it. So try to give everybody the opportunity to see this indicating work whenever I get the opportunity to show it. The jaws feel tight. Now I got it where I want. I just want to go around and make sure all 4 of them are snug, that I didn't miss one during indicating, and one of them's loose. So we're going to be pretty good right there where we're at. This original piece, so it measures about, it's a little under 6.5, so I'm going to make it 6.475. That's about the highest spot that I'm getting on that. So we'll just make it that. Maybe it needs a little bit of clearance for 6.5 inches. All right. 50, 75, 85, 90. Still got 90 thousandths. We got the lathe compound set up on the right angle. We're going to go in there and just cut that bevel in there. I'll be hand feeding the compound here. We've got our bevel machined on here as we need, and I decided I'm going to go ahead and clean this ID out a little bit. It's slightly smaller than the original piece. That's just how, you know, the sizing this tube came. I've got a little bit that I can work with there, so I'm just going to, I really just want to clean it up. That's all we're going to do. Just kind of make it look a little bit more uniform. We don't really have to, but because this taper is going back further than the original, it looks a little bit different, so we're going to go ahead and skin that out some. I'm reaching through there with my chamfering bar to chamfer that back edge there, so I don't have to do that again after I take it out of the machine. Well, there's our lathe work finished up, and we've got it nice and polished, looking good. I'm really happy with the way the bore looks. It just looks like a more completed machined component there with that nice machine bore through there. Didn't have to have it, but it was just something extra that I wanted to do anyway. So I'm happy there with it. It looks good, so I'm going to take it out. We got to go to the mill for our last op, which is going to be drilling and tapping the flange there for 4 holes, and then that part will be done after that. We're getting her set up in the mill here, and I want to show you how I get this squared up, because I want this square to the axis of the mill. And just to keep it super quick, easy, and simple, I'm going off the side of the vise jaw right here. This should be nice and square, and I'm going to use this 12-inch machinist square right here. Clean the jaw off, and what I did was I just butted up to the jaw and went underneath the flange, and just what I did was eyeballed this corner and this corner to where it's just touching the edge of the blade there. So that should be nice and square to the axis of the mill. So once we center up and we do our hole pattern, we should be near the center of each one of those little ears. Another look at it, in case you couldn't see it from the other angle there. Point there and there. To get this thing centered up closely, I'll use my center point there and my 6-inch scale. I mean, just do like this and represent. So we're 5 1/8. That's going to put us just over 2.5. I'm going to use this style indicator here. One of my favorite setups to be able to use. Pretty close there. We're getting a little inconsistencies with the tube. So let's come up here on the ring and see if it's a little bit more round. Let's go ahead and true it up there, because we know our whatever's going to register here is what's going to bolt up right there. All right, we're going to set up our DRO for our hole pattern there. So first thing we need to do is just zero out. We finished indicating it. We're on center. So we'll go to F for function. We're going to go to PCD, pitch circle diameter, enter. Pitch circle diameter. And so our bolt circle is 7 1/4, 7.250. Number of holes is 4. Angle, we're just going to start at, no, I'm sorry. Okay, yeah, we're going to go 45 degrees. I was thinking of that wrong. Okay, 45, enter, go. All right, that's going to be hole number 1. And we'll go ahead and check that. We'll spot 2 in and make sure we're on our true 7 1/4 bolt circle. Let's just spot number 1 in. Just going to make a little divot right there, and then we'll come over here. This is 1, 2, 3, and 4. We'll spot in 3 and measure that. right down in that divot. That should tell us right where we need to be. So 7 1/4, just like we need to be. Let's go ahead and start our drilling and tapping. So by the way, these are going to be 3/8/16, so we're going to use a 5/16 drill bit for our tap size, and then a 3/8/16 3-flute gun tap to just through tap it. I sometimes like to pause right there at the end just to help cool that drill bit down. It gets a little hot as it gets down in the hole further. Put a nice chamfer on it. Now we're ready to tap our hole. So we're going to be using, this is Molly D cutting fluid, tapping fluid that I've got in this can right here. Good for stainless. We'll clean this off really good once we're through with all the machine work, because this stuff has a pretty potent smell, especially if you get it on you. Usually I'm wearing my orange gloves. I just haven't put them on today, but that's some good stuff for stainless steel at Molly D. Went ahead and put my gloves on anyway after saying that, not having them on. I don't like getting that cutting oil all over my skin, especially this stuff right here. I've had several guys ask me about concerns of using the mist coolant on their machines and causing rusting issues and things like that. And I just wanted to bring this into the video since I got to clean it up. Anytime I use my coolant mist or coolant, I always come back and clean the machine. And I use WD-40 to get rid of any of the water that's in the coolant. So I'm going to go ahead and spray this on there and give it a little wipe down. And the WD-40 will actually help remove any of the oils and other chemicals that are on the machine as well. But I'm just getting it initially cleaned up right here. And just come back with your WD-40 and just coat it down. And you will not get any rusting issues that way with using that mist coolant if you clean up after and keep it coated down with some WD-40. Got to get in here and deburr these back holes. I'm going to use this Noga deburring tool right here just to extend it out. where you need to. There it is, guys. We have a completed component now, and I'm happy with the way it turned out. I went ahead and give this area a little bit of a polish over on the 3M polishing wheel, and I deburred that edge there as well. That was just a filed edge, but I wanted to kind of really soften it up. Couple imperfections here and there that I'm not happy with, but overall it's going to be a good piece. You know, we got a couple spots there where we hit it with the welder, but this isn't this face I don't believe is used. I believe it's just pulled up there. This being a register. That's it. It is ready to roll. Just got the other one there sitting next to it so you can kind of see in comparison. So that was one piece of the puzzle right there. You know, we've already got the other videos on these other components, so we finished those clamps already. So we got those guys, 4 of them, and then we got this clamp right here as well. We got 4 of those clamps. All these go together for this job, and we got our sample pieces right there. And there it all is. I hope you guys have been enjoying following this project. This was a pretty good job for me to get down here in the shop, and I enjoyed bringing you along and sharing it with you. Hope you all enjoyed, and come back for some more, and we will see you on the next one, okay?